All right, day two, about ready to get started. I said we're going to go back and do some things with chapter nine, with pointers to see see a little bit of review. But if I asked you what are the top 10 things that oh, I don't want that. The top 10 things that you remember from CPS 161, what would you say they were? The dreaded C string. I'll get you started. Remember dealing with C strings? That was before there was C++ and classes, and we had to work with this like it was a character array. Okay. Another thing we did, we started looking into sorting, and we talked about three types of sorts. One was an exchange sort. One was a selection sort where we selected an item and then moved it. So it was the selection sort. Finally, the last one was called an insertion sort. Well, we hit the tip of the iceberg with sorts because in this class, we're going to check out new ways to do sorting. Blow your mind, hopefully. Um, I just mentioned chapter nine, and that's the ever popular pointers. We're going to do a little bit of work with pointers here coming up. Um, did a little more file work than you did in 121. All of a sudden, you're starting to say, wait a minute, I maybe I did learn something last class. We did some recursion, starting to do some. Yeah, this one's big. A struct. We're going to do a lot of stuff with struct. We did something called an enum, and that was actually a data type. We created a data type that we wanted, just like the struct. It was a what do we want inside of this? And it was an enumerated data. We didn't have much use for it, but it's in this idea of creating new data types, the way we're storing some things. Oh boy, yeah, we got into vectors. Remember getting into vectors a little bit, and we talked vectors versus arrays. And that's not going away, these two concepts. This is big in this course. Okay. Oh, vector. A vector was something that was called dynamic. And some of you liked vectors a lot. And some of the stuff we're going to do, you're going to see how it mirrors vectors, but it's going to be a little bit different. Dynamic in that this would grow if I needed more memory, or I could shrink it if I needed to and use less memory. This guy, an array, was static. Okay. And once we determined the size, it stayed the size. Now, this is kind of all one big ball. As we go through this semester, we're going to be creating data types. And as bizarre as it is, we get this new data type concept, and then we say, can we use a dynamic structure or can we use a static structure? And we're not going to use vectors. We're going to create our own that's dynamic. But there's going to be times where using an array to work with this new type of data is going to be good. One a vector was actually good. Not a lot else. We got into some multi-dimensional arrays. And if I listed one more thing in my top 10, I would say we talked more about algorithm writing and how you could take a program and jot down what you need to do and do all of your thinking ahead of time. And then coding got a lot easier. And in this class, you're going to hear me say, along with the algorithm, draw the picture. You're going to hear that quite a bit. And the other thing you're going to hear as well is draw the picture is more and more like algorithm writing is what's your test data? Going back to 161, the emphasis was a little bit of, I want to write in that, oh, maybe I need to do the test data first and make sure I understand all the math and the work's going on. And then I can come up with an algorithm second with formulas and so forth. Well, this is going to fit right in there as well this semester. The ever popular draw all the picture. Okay, capiche? The other thing we did a little bit of work on that we just talked about briefly, this ever popular UML chart. You're going to see a lot of this in CPS 230. We had the class, we gave it the name rectangle. And then we worked through going from there. We did the constructors. We had fields first, then the constructors. So the fields were here, constructors were here. Then we had all of our methods. So let's keep some of that in mind as well. We talked about overloading. Wow, clue structures? How about an N? I don't know what's the opposite of dyslexic where it's backward. Instead, I put it upside down. I'm upside down lexic? No, maybe not. Okay, that means I should stop talking. All right. So today we're going to start out by getting another piece of paper, going back to chapter 9. Da-da-da-da. Chapter 9. Oh, where are we at here? Whoever invented the dot cam did a great job. Shooby dooby doo. X equals 25. I'm okay with that. That line of code's not too bad. Int, asterisk, pointer equals. What's the pointer have to equal? No, don't tell them. Pointer gets it has to equal an address. And a lot of times when we initialize it, we're going to initialize it to null pointer. Uh, or null, depending on the IDE you're working with, or we can just do 0, which is what I do a lot of times. I just set that address up to be 0. Do you like that line of code? Pointer gets the address of X. All right. Thank you, Protector. Hey, what about this line of code? Pointer equals 100. Somebody tell me what that does?
It changes the value of X, right?
This goes to the location. What this asterisk is called the indirect operator. Indirection operator has two different uses. One, it says this is going to be the address stored at the name pointer. Here it dereferences the value, dereferences. Yeah. This will go and change what is at X. So for example, X might be 25. Pointer gets the address of where this is, putting the indirectional operator first. If you look back through chapter 9, we mirrored how arrays worked. An array name was just the address. Tell me if that sounds familiar. Do 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 do. I'm gonna get my book. I love my book. Do 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 do. And we have things. We have things like. Here we go. Here's an array called numbers. If I just said numbers, I'm going to use the address. Just numbers is the address. Here I'm passing it into this function show values. Okay, so numbers is just an address. I can set that address to a pointer if I want to. Down here's another example of initializing a pointer. Pointer gets the address at 25. That's something we had just looked at. Get over here to addresses, to arrays. If I come in here and say cout numbers, that's going to give me the first value. I'm dereferencing it, dereferencing that address. Numbers is an address. The little subscript after it said, hey, move over short number of bytes each time. So if it was a 1, it would move over short bytes, whatever that was. We saw things like this. Numbers plus 1. Dereference it, gives me the value. Again, working with a short was like multiplying it by 2 to keep moving it over. Familiar, vaguely familiar? Here's another example. Here's an array, creating a pointer. The pointer gets the address of the array because coins, the name of the array, is the starting address. Hold some kind of hex, gibber, 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 gibber. So we're going to see these pointers and a bunch of stuff coming up that if you need, scramble back to chapter 9. I'm scrambling. Okay. Questions. Little bit of chapter 9 review. Cool. All right. Chapter 14. We're going to take a look at the first 3 sections today. We go at your pace. If I'm going too fast, slow me down. If I'm going too slow, start yawning. We'll figure that out quick. First page, I have my notes. Let's see. We're going to now talk about something that's called static. We've seen this word static quite a bit. Static. What is static? What is static? Well, in C++, we're going to start with a static member. A member. A member is a variable, okay? It's going to be a variable. We're going to declare it of type static. Now, what happens here is this, and I'm giving you the overview first, does not belong to any instance of a class. And you're going, what the heck's that mean? Now, let's get into actually what's going on. I have type in 14.1 and tree.h. So right now on page 819, you have tree.h, and then right after it is code 14.1. So I'm going to pause the recording for a couple minutes. So again, as we're finishing up here, changing the word define to instantiate. I did instantiate 3 objects. None of these objects have their own real variables. The only variable from the tree class is this static one right here, this object count. And like I said, it's kind of owned by tree. And then I can pick any of my objects, call the function get object count, and it gives me the value 3. Questions? Questions? We're good? Okay. That's a static variable. Yeah, when I come back here, does not belong to any class. You know, back before we had length and width, and they were unique to every object. They were unique. Yeah, we don't want that anymore. We want the class tree to have an object so that it stays forever. Define it at the end of the class. Okay. Next up is a static function. If you jump on to D2L, and I want you to now grab 14.3 budget.cpp and budget.h. Ta-da, I don't have to type it in. Da-da-da-da-da. So this time you're taking a look at budget.h. It says version 2. I have that. Did anybody happen to check to see if that definitely was, if not defined?
Yeah, I
Somebody,
checked. I'm pretty sure it is.
excellent. I never really put any thought into it. So if it's not defined, budget underscore H, that's a little define it. So line one, line two, and at the very end, we have that end defined. Okay, I come in, I have my static variable. Cool. I actually have a variable that each class will be able to own. Excuse me, each object will be able to own. Again, this is like the class's variable. This is going to be like each object's variable. Do you notice when I call the constructor, I set that variable to 0. I have an inline function defined. The work is there for add budget. It brings in a value for a budget. It's going to add it to the division. The division one is owned by the object, and it's going to add it to the corporate. The corporate is owned by the class. Write that in your book. I will. This is owned by the class. This one is owned by the object. Does that make sense describing it that way? This one goes away after we're done with the object. This one stays forever. I have a couple of two more. Uh-oh. I have another function. Notice this function starts out with the word static. Well, this function is now going to be owned by the class again. Let's come down and take a look and see what's going on. I come in here and all of a sudden I get ready and I define this method as everything's being added to this amount coming in, this double. The argument is coming into the parameter list, is going to get added to the corporate budget. All right, let's see how this works. I come in and iOS stream IO manip. What is IO manip for?
Is it for like decimals, like formatting decimals?
We're going to see in a couple seconds when we look down through what's going on here. I'm hoping you're right. All right, I come in and my main, I have a variable and another variable, and that's all good. I come in, enter the main budget, main office, knows where to go, up above. Oh boy, we got a lot of stuff in here. Yeah, it's good I didn't have. See, this is part of why not typing code listings in. They're getting long quickly. All right, I come down and oh boy, what's going on in line 19? Uh, oh, this is nice. It tells me what's going on. Sometimes I forget what these hieroglyphics mean, but documentation for me, for you, for the next person to use your program. I'm creating an array. Here's my array name divisions. Again, we talked about that being an address. This is the size of the array. This is what's being stored in the array. Objects from the budget class. Yep. I'm going to come down. I'm going to fill the array. I got a lot of good stuff going on inside of here. I come down, line 32. Ding, 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 ding. Looks like Logan was right. We need that IO manip. This was yeah, some stuff we did in C++ last February. Yep, February. This is letting me go and work through everything I need to do. So, what are we talking about in this one? We need to back it up a little bit. We come down to back to the .h file. We've created a static function. This is a static member function. This can be used anywhere. Another example of static functions. They were written and they did not need to be used on a particular object. So I'm going to do this. Written for anyone to use. And a perfect example of that is if we think back to our math class, math.square root, that was a function, that was a method, square root, that was written that we didn't need an object to call it on. Okay. It was written in a way that we don't need an object to call main office. So let's make sure over here that that's what we're getting. And where are we at here? Line. Main office. I don't even see it in there. Where are we at, folks? Here it's written. Here it's defined. Here it's written. We're adding to that. Oh, I apologize. Here it is in line 17. I even highlighted it. This is me calling from the class a method, but you notice it's not a method or function connected to an object. Not connected to object. Capiche? It's a little bizarre. There may be times when you want to use something like this. You may be writing functions that you don't want to have connected, but might deal directly with it, but it works for any instance of the variable. Boring scale, 1 to 10. Let's not go there. Let's not go there. Okay, so static. And again, going back to 14.1, the very first thing we looked at, the static variable and how it's independent of each of the objects that we instantiated a tree. Okay, keep going. Don't bore them, Dan. Don't bore them. All right, 14.2. So you remember creating classes a long time ago. And in classes, we had private members. Here we go. We had private members. He actually does a good idea phrasing his concept for what's coming up. But way back when, we had private members of a class, which means I could only access them in that class. Well, we can now write a function or a class. We could say, hey, we're writing you, you're going to be a friend of this other class with private members so you can have access to it. Trust me, in the next chapter, things get a lot more exciting. You can be a friend class. All right. How about y'all go and load up what's going on here in D2L? Do you have budget.h version 3? Auxiliary.h, auxiliary.cpp, and I don't know why they have it in there twice, 14.4. When I first started at Hack, there was a guy teaching comp sci in a classroom, teaching it without a computer, doing everything by hand. Could you imagine me up at a chalkboard writing all this stuff down by hand? No, let's not do that. All right, as you're loading it up, shooby doo, we've been working with the budget a little bit here, but oh, look at line 3 of budget. Include auxil.h. And as you went and got those and you loaded them up, you noticed that auxil is its own class. Auxil was a class broken up into a spec file and an implementation file. Auxil is its own class. It has its own spec file and its own implementation file. So shooby dooby class budget. We looked at all of this. There's my static variable. I like that. Nice. It's independent. Shooby dooby doo. And down here at the end is where I'm going to give permission. I'm giving permission to a function, and I'm going to allow it to use my private members. So this auxiliary office class has a function called budget. When I call it, I'm going to send in a double and the address of a budget object. Easy to get lost going through this. Remember, I said this is going to be a hard course, but if I can do it, y'all can do it. At the end of my budget class, I now have added a friend function. The function over in the auxiliary office, the function is called add budget. When I call it, I'm going to send a value and an address over. Questions on line 29. If I told you to type it up in the comments and I'm randomly going to pick someone's comment to see if they could explain it, could you explain it? Maybe. That's the way to think about it. All right, let's keep going here. I have auxiliary class. Auxiliary class. Okay, I'm defining it. I'm doing a forward declaration of budget class, which means, hey, I'm going to be using budget class. Just letting you know we're connected. Auxiliary class has a member, a variable. It has a constructor. It has a function called get division budget. It has a function called add budget. This function add budget is the one that has permission. This one has permission to use budget's member, budget's private member. It has permission to use, oh, you can't see it. I can see it over here. Budget's private member. Okay. So let's see. That was the spec file for .h. And here we're getting ready and we are sending an address in, yada, yada, yada. But we are working and messing around with, here it says here it says division corporate budget. And over here is corporate budget. They look a little different, but remember we're passing the address. Okay. Conceptually, do you understand a static member? That was over here. We had a static member. We had static functions like math dot square root, except we don't say math, we just say square root, and it knows that we can use it. And how the idea of a friend works. Now, are you going to remember all this syntax? No. I have to go back and look it up every time to figure out all the logistics. Is this a topic that we spend a lot of time on? No. Do you need to understand how it works and that it exists? Yes. So that's like I heard a conversation earlier on. Well, no, you can't access the a class's private members. And then somebody said, well, you can technically if it's a friend function. Yeah, technically you could. Deep.
Could you just explain line 29 just one more time?
Sure. Right here. Right here, this one. Yes.
Yes, yeah, that
I'm
one.
using the reserve word friend. Okay. Over, I have auxiliary office. Do-do-do-do-do-do. Do-do-do-do-do-do. Where are we at here? Auxiliary office is the name of the class. I don't know why that's not auxil. Instead, it's auxiliary office because I'm getting the function add budget from it. Oh, I apologize. It's down here. It's when I do auxiliary office is this class, auxiliary office. Okay. So 29 is saying go to the class auxiliary office because we always put the class first. Use the function add budget. The declaration of the function has a double coming in and an address. Okay. When I'm doing this, it's actually going to allow me to use, I'm saying, auxiliary office, you're my friend. And when you use this function, you can have access to my private. Sounds kind of dirty.
So it's like you can look at another class,
Yep.
but use your own function
Yep.
and operate that on a separate class.
Exactly. So in this class auxiliary office, I'm going to be able to use the private variable over in budget. Couple syntax type of things I have to do, like this forward declaration, etc. Down here, you add budget, which it's gonna get, it has permission. So when I work with add budget over here, I'm using stuff from over in here. I'm
If
using corporate budget.
if auxiliary office were to have privates designated privates to the auxiliary, would it still work via the friend
I
command?
have a private here in auxiliary office, okay, but the budget class can't use it.
Okay.
This
Even when
is
it declares
yeah,
friend.
unless they're a friend and give permission.
Okay.
Yep. Good
With
questions. I think maybe that cleared up a little bit of what it's all about.
with the friend function, I see that we can reference it, but can you actually manipulate the variable that's in budget to store it in that address?
Right here, we're adding it. We're adding a value to it. So we're going to the auxiliary budget, which is excuse me, the corporate budget, which is here. And if you look at it down here, we're adding a value and changing that corporate budget. So this guy right here, is the private over in budget. And I'm manipulating it. I know, right? Here's the object name, division. It's a data type of budget. So I'm using that name. This is a budget object, the address of a budget object. So then I'm going to go and use that object and call and change its value. Getting a little cleaner? Yeah, it's one of those I can explain it, then I need you to ask questions to figure out where the holes are. So this is in my parameter list. I'm creating an object of type budget that's called div. Div's going to start with the address. When I use just div, it's now going to let me use corporate budget and change it. So whatever that corporate budget was before, I'm now changing it. I'm adding B to it. Yeah. Yeah. Again, that's syntax wise, it's crazy. Whoever created Java, Bjorn Strausstop, must have had some kind of craziness going on to think all these different levels. Remember, ComSci is still fairly new, and how it just keeps growing and growing and growing. Shooby dooby doo, shooby dooby, dooby dooby doo. Let's see. Section 14.3. Section 14.3. We're going to start, and it's kind of weird that it starts simple, but we're going to talk about the assignment operator. The assignment operator is this equals, and we'd like to be able to, well, no, wait a second. If I created a variable rectangle, and I created the variable R1, rectangle is this like mother class of ours. It's just great to use. And we all remember rectangle has its own length and its own width. Okay. If I created actually get rid of that and I threw in a second object and R2, I could call it R2 D2. No, it has its own length and it has its own width. Yeah, none of these are static. Static wouldn't be owned by either one of these. Like I could have a static variable area, which would find the area of R1 and add it to it, find the area of R2 and add it to it. And, I could start to plan how much lumber I need to buy or something. Static variable would work nice that way. Is this R1 assignment operator, R2, is that legal? Bueller? Somebody guess?
No.
There's a guess of no. Does anybody want to guess yes?
I would say yes. That should be
Okay,
fine.
there you go. Thanks. Just to keep things moving along, right? I need to make sure you folks are still there. Is this legal? The answer is Logan. You're wrong. It is yes. It is yes. What's going on here? What is R1? It's an 1, 2, 3. Yeah. We were to play Hangman. That's the old days.
Address.
Yeah, it's the address. So what happens here now is R2 is an address. This guy now points to over to here. So if I said get length on R1, it would give me 41. If I said get width on R1, it would give me 100. This would now be lost in memory. So this is legal. Is this really what we want to do? Well, no, maybe. It might be. I may want to copy the address. Chances are that's not what I intended. And what I intended was probably I wanted to copy the values. And when I'm doing this, this guy, when I'm copying the addresses, is actually referred to as shallow. It's like a shallow copy. You're getting the values from over here. Over here, what I want to do is a deep copy. And I'd like to get everything that's in R2 and move it over into R1. And in order to do it, the solution is 1, 2. The first solution is called a copy constructor. Oh, oh, okay. A copy constructor. Well, I'm thinking a copy constructor is going to look like, think about what we would be doing. Instead of this line of code, what type of line of code would I be putting on there? Well, let's see. I might be doing something like rectangle. I would be instantiating an object like R1, and I would be passing in an argument of R2. Now, inside of R1, when it's being created, R2 is being passed in. Actually, its address would get passed in. Once I'm in there, I could take the values 41 and 100 and actually copy them to the local length and width for R1. A constructor. I'm instantiating an object. The object's called R1, and I'm going to send R2 in so that its values can be copied over. Ah, okay. Number 2, we're going to learn about something new, and it's called operator overloading. Operator overloading. We're going to actually learn how to overload the assignment operator. Have you seen overloading before? Check this out, Funk Soul Brothers. Let me get this out of the way. Check this out, Funk Soul Brothers. Num equals 6 plus 2. Num equals 6 plus 2.0. Let's call that num1. STR equals high space. That's my old COBOL days. Did you ever hear the language COBOL? COBOL. Common business oriented operating language. Common business operating language. This was big for businesses, money. You know, they use this language and its features. We now have one language, two languages that do all kinds of stuff. But back in the day, BASIC was your simple language. Fortran was used a lot by engineers. Businesses use because it only did certain things. The language was small and created for just certain things. Now we're doing C++, which covers we can do all this, we can do all this, we can do all the basic things. What's BASIC stand for? Ah, hope none of you go on Who Wants to Be a Millionaire. Beginners, all purpose, symbolic, instruction code. Formula translator. Okay. But anyhow, that B represented a space in COBOL plus double quotes mom. Is this an example of an overloaded operator? The answer is yes. I'm adding an integer and an integer. I'm adding an integer and a double. I'm adding a string and a string. So the plus sign is already overloaded. How it works is it says what's on the left, an integer, what's on the right, an integer. There's code written to add integers. What's on the left and right? There's code written to add strings. So this plus has functions. Oh, it's got lots of functions written to tell it what to do. It's an overloaded operator. We're going to overload this operator so that the original one that copied addresses, we're going to now overload it with code so that this now does that deep copying. And where are we going to do that? We're going to do that in section 14.4, which we are going to start next Wednesday. Whole lot of stuff going on here in those three little sections, mainly concepts. We never got to play Hangman. That's old school, right? Yeah, oh, he died. That's a game people were going. I don't know why, but that kind of doesn't exist anymore. Questions on 14.1, 14.2, and 14.3.